Darry, this is part 2 of the Cromemco test system build, which is the machine you see on the right. So I've made some progress. It's been a bit fraught. So what have I done? I've looked at the configuration of the working system, which is over here. And recall, this is a system I don't want to touch too much because it works well. And as a working system, it's good. I wanted to build a test system that I can pull cards in and out of and have it hopefully still work and test cards. So this is the test system, and I'm trying to get the floppies to work. Now, from left to right, I sort of have a working configuration except something's wrong. So this is the first, this is the 3.5 inch floppy converted, although it's not properly converted as I'll come to look like an 8-inch drive. This is a 360k floppy. This is the original floppy from the Cromemco system. So that's dated 1990. And this is the HXC floppy emulator here. So that can emulate 2 floppies. I had selected A and C, then it was A and B. Now it's back to A and C. So the next thing you need to know is let's look at the cable that goes from the disk controller to the floppy drives, and this is a cable that I've taken from a IBM PC type device, and we'll look at that and see what's going on. Okay. This is an IBM PC floppy drive cable. So at this end, you connect to the disk controller. So the IBM PC copied, by the way, designs of a slightly earlier age, and this computer, the Cromemco computer, is a slightly earlier age. It uses the same floppy cable and uses the same floppy technology. This is the end that would attach to the disk controller, and then you've got a number of drops here. You've actually got 4, and you've got the smaller connectors and the larger connector. The larger connectors are for 360k drives, and these connectors are for 1.2, 1.6 megabyte drives, if you like. What I found out was that I had to mess around with the cable. This is an identical cable to the one that I've modified. So in order to cut costs effectively, what IBM did is they made a twist in this cable here. And this, what they would ask you to do is to, I think it was, assign the drive as drive B, and this twist would twist it round to A. So if you had a drive on this end here, it would be B, and that would twist round to A, or vice versa. So this would enable you to have a floppy drive, 2 floppy drives on the system. What the old standard was drive 0, 1, 2 and 3, which would map normally to A, B, C and D. And so it doesn't require this twist. This twist was a sneaky way of trying to simplify the floppy design, because then you could design a floppy drive and switch from drive A to B with just all drives being connected the same. In fact, some later floppies didn't even have a selector switch, and they just were connected to effectively, I think, A or B, and using this cable you flipped between drive A and drive B. Anyway, the older drives, like on Cromemco, have got DS0, DS1, DS2, DS3. That's mapping from drives 0, 1, 2, 3, which in letter terms was A, B, C and D. So what I've done is I've modified this cable to how it should be, really, which is without the twist. I've chopped it here because I only actually need 3 connectors. I need the first one for the HXC. I need the second one for the drive D, which is the 360k drive. And I need this one for the 3.5 inch drive, which is pretending to be an 8-inch drive. So now we're going to go and see what's wrong with this configuration, because it's still not working. Okay, so we have started the system, and we're now going to give a little exercise. So the system started, it's waiting for me to hit enter to auto determine the baud rate. So I'm going to hit enter a few times. I'm going to try and boot. I'm going to press escape. It's taken that. Now, the double drive, which is the HXC emulator, is on drives A and C. So we'll do a B, C to boot the C drive. And that should boot. Don't forget, this is a 1978 to 1982 to, say, operating system called CDOS. It's running in 64K total memory, of which CDOS is taking about 20K, something like that. Okay, so, oh, we've got a visitor. Come in, baby. Can you shut the door? No. No, it's upstage my video. Everyone's been looking at you, not me. Okay, so if we do a DIR, we can see everything seems to be working. And the A drive is another virtual drive. And I did a copy. The copy took about 30 minutes and didn't actually finish completely. So the A drive and the C drive, which is the virtual drive, seem to work flawlessly, as I might expect. Now, you can't quite see it, but there's I'm pointing to the 360K drive, which is a 5¼ inch drive. That's got a diskette in it, and it's the D drive. So if I do a DIR of the D drive, which is already formatted, that works. So if I do a stat of the D drive, come on, old girl, you can do it. Okay, so you can see we're running CDOS 2.53. We've got 64K total memory. The OS is 15K. We've got 49K left. The master drive, the boot drive, is the C drive, and the drive that we're looking at right now is a double-sided diskette, is double-sided double density, and the drive is double-sided dual density, so single density and double density. So that's all working. And if I was to do an init, which is the initialization of the diskette program, if we try and initialize the D drive, we won't finish. The operating system looks at the index pulses that are coming from the hole in the disk drive, is triggering those index pulses. There's an optical sensor that looks at the hole as it passes every 310 RPM. So nominally a 5¼ inch drive rotates at 300 RPM. This is rotating a little bit quickly. We've got some formatting options now. So now I'm going to look at the drive number B, which is the drive which isn't working correctly. And I found out what the problem is. So if I type the init command, so this is a 3.5 inch drive which has been specially converted by me 10 years ago. Never tested because I did the conversion and didn't ever bother to test it because I hadn't a spare system to test it on. So that is the B drive, and I'm about to find the problem. It's rotating at 309 RPM. So the problem is, when I write to that drive, which I can do, it starts to work, and then it has all sorts of errors because it's spinning at the wrong speed. So the data's coming through at the wrong speed, and I get all sorts of errors. So you can see it says 309 RPM. Just highlight that, and that's the error. So I'm going to take that drive apart and see why it is rotating at 309. And it's such a long time ago, I've forgotten how I electronically converted it. It was some jumper wires, I seem to recall, which forced the speed. So yeah, I've got to find that and figure it out. So that will be the next video, maybe looking at the diskette drive and trying to see why it's revolving at that lower speed. Because in this case, I want to fix the speed to be always at 360 RPM, which is the correct speed for an 8-inch disk drive. Okay, Darry, that's it for now. Okay, I've made another electrical modification to this drive, this Samsung drive, which will hopefully enable it to emulate an 8-inch drive. Okay, Darry, we're having another go. Proofs didn't work. I'm trying to pull a pin low in order to force the 360 RPM, I think what happens when I originally tried to convert this drive, I snapped the wrong pin on the external interface, and so that pin can't be pulled low, and so I'm trying to pull it low in another way. Let's see if this works.